Great job on your last mission. Here's your next mission. Sail.
Thank you, Mr. Franklin. It's dark night. I'm here to learn the secret of logarithms to save the world.
Well, you know, logarithms make me very sad because I'm related to the guy who invented them, and whenever I think of them, I just think of him and how much I wish I could have met him. So, logarithms are written in the form of bacon and eggs, which means base, answer, exponent. If b of x equals y, then the log base b of y equals x. For example, if 3 squared equals 9, then log base 3 of 9 equals 2. Simple. The common logarithm is just a way of saying log base 10 of x, which equals log of x. It just means that you don't have to write the 10 when you write log x because it's insinuated that log base 10 equals log. So, logarithms are written in the form of bacon and eggs, which means base, answer, exponent. If b of x equals y, then the log base b of y equals x. For example, if 3 squared equals 9, then log base 3 of 9 equals 2. Simple. So, the natural logarithm is the same concept as the common logarithm, except instead of log base 10, it equals log base e. That just means when you see ln, it just means log base e of x. As you know, e equals 2.72, Euler's number. So, when you're finding an inverse of a logarithm, it's really simple. You just switch the place of y and x and then solve for y, so you'd finally get y equals 2 to the x.
Log 3, 27 equals 3, right?
Correct!
But I still don't know how to graph a logarithm.
Well, you know, I can't help you with that, but I do know a guy. Here's some plans so you can find him.
Bangladesh. Thank you.
No worries.
I have to go.
Something's not right.
I need to know the secret of logarithms. Oh, my heart!
Not my wife!
Mother! It should have been me!
But I suppose if it will help to save the world. Properties of logarithms are used to expand or condense an expression. These logarithms have all been expanded using different product, quotient, and power rules. In log 3 of 3 times 81, it'd be the same as log 3 of 3 plus log 3 of 81. And log 4 of 256 over 16, you'd subtract, because that's the quotient rule. Review: when multiplying you add, dividing you subtract, and when it's raised to an exponent, you can put it in front of the logarithm. Does that help?
Yes, but I still don't know how to graph logarithms. And we're running out of time. Why can't you teach me?
I'm afraid that's all I know. The only person who can help you is in Prague.
I'll go there immediately. Thank you for your help. I'm sorry about your mother.
Before you go, here's some stuff for you to read along your trip.
It's a letter from the director. My ticket to Prague. Thank you for your help. I'm off to save the world.
Try your best, but you don't succeed.
My name is Dark Knight, and I'm here to learn logarithms.
What's your real name?
I'm afraid I can't tell you, and I definitely do not work for the CIA. It's the NSA.
Let's get started. Sit down, take a seat. Graphing logarithms is as easy as 1, 2, 3. Step 1 for graphing a logarithm is to make a table for x and y. And now we will put in some x values. First, we put in 4. 4 minus 3 is 1. Log 2 of 1 is 0. Then we graph. Next value, 5. 5 minus 3 is 2. Log 2 of 2 is 1. Next value, let's try 3. 3 minus 3 is 0, but log 2 of 0 is not real, so we write undefined. Right. Yeah. 3 is undefined. That means we can conclude it is an asymptote. Since this is a logarithm, we can conclude that y is all real because they go all the way down and all the way up. However, the x values are called the domain, have to be greater than 3 because 3 is undefined. So therefore, we would write x is greater than 3.
I still don't get it.
Practice some more. Let's graph some more. First, let's do log 2 of x. Log 2 of 2 is 1. Log 2 of 4 is 2. Log 2 of 1 is 0. Let's try 0. Log 2 of 0 is nothing, so we have to write undefined. But, however, we can do fractions. Let's try one. Log 2 of 1/2 is -1. Let's try another. Log 2 of 1/4 is -2. As you can see, this graph is approaching the asymptote, which is 0, but it never actually touches it. So x equals 0 for the asymptote. X has to be greater than 0 for the domain, and y is all real.
The range always all real?
Why, yes, it is in a logarithmic graph. Now get back in your cage.
I can solve this now. Y equals log base 5 x plus 3. I'll make a table first. I can do -2, 2, and 22, just for example. Now, -2 plus 3 is 1. 5 to the 0 power equals 1. 2 plus 3 equals 5. 5 to the first power equals 5. 22 plus 3 equals 25. 5 to the second power equals 25. Now, I need to graph it. -2, 0. 2, 1. 22, way back here. Just do that. So the log, or arithmetic function, goes like this. Now if I plug in -3, 5 to the nothing power is undefined, which means that negative 3 is the asymptote. So if we continue the graph, it'll go something like this. But what does it mean? Putin's plan to take over the world, starting with a graph of his mortgage. Director, I figured out what Putin's doing.
Good, Putin's already there.
Oh my gosh.
Don't ask why I'm a banana. I came from a party in Siberia.
You're trying to take over the world. Not on my watch. I have the power of law. Director, he's defeated.
Your next mission is on its way.
Algorithms are very easy if you can remember what to do. An easy way to remember what to do is to use bacon and eggs, which stands for base, exponent, and answer. Here you can see log 2 of 8 equals x. The base is 2, the exponent is 8, and the answer is x. This is the same thing as 2 to the x equals 8. Here you can see 2 to what equals 8. 2 to the third equals 8, so x is equal to 3. Logarithm is one that is inferred that you have a base of 10. Here you can see log 100. It would be the same thing as log 10 of 100. You can use the calculator for a common logarithm. This can be plugged in on your calculator by hitting the log button and then typing in 1000. You see log of 1000, but the calculator reads log 10 of 1000. The answer here is 3. A natural logarithm is when you use base e. E is Euler's number, which is about 2.72. Log e is the same thing as ln. ln of 7.389 is the same thing as log e of 7.389.